The diagram shows the triangle BCD and ABD with some measurements given. A, part 1, find BC corrected 2 decimal places. So we're trying to find BC corrected 2 decimal places. So the first thing you want to do is have a look and see, is this a right angle triangle? And it's not. So we can't use Pythagoras' theorem or SOHCAHTOA. We're not looking for the area, so we're not going to use the area formula. So our options are the sine rule or the cosine rule. And you should always try the sine rule first, because if that doesn't work, you can use the cosine rule. We're going to relabel this capital D as capital A. So if this is capital C, this is lowercase c. If this is capital B, this is lowercase b. And if this is capital A, this is lowercase a. So then we're going to write out our formula. This is the sine rule formula from page 16. So the sine rule is A over sine A equals B over sine B equals C over sine C. So then we start to sub into the formula. We replace lowercase a with, we can leave it as A or just put it as X if you want, because that's what we're looking for. Sine capital A, so angle A, we replace the A with 42. So that angle there is 42 degrees and we've labelled that as capital A. Lowercase b, we don't have anything to replace that with, so we can just leave it as lowercase b. Sine capital B for the angle. We don't know what that angle is, but we can figure it out because we know these two angles here and the three angles in a triangle add up to 180 degrees. So we can replace that with the angle if we want to. And then lowercase c is 16. And then sine capital C, so for angle C, is 110 degrees. So sine 110 degrees. So I'm going to call this X. You could leave it as A if you want, but I like to call it X. And to figure out what capital B is, which is angle B, 180 degrees minus 42 degrees minus 110 degrees is 28 degrees. So subtracting 42 degrees and 110 degrees from 180 degrees, because the angles in a triangle add up to 180 degrees, leave us with 28 degrees. So that's 28 degrees. So we can replace the capital B there with 28. So even though we know now sine 28 degrees, we still don't know what that B is, that lowercase b. So we actually can't use this ratio at all. So we can cross this one off. But the 28 degrees is going to be useful later on. So we have X over sine 42 is equal to 16 over sine 110. Then we're going to cross multiply and solve for X. So we're going to do X times sine 110. Bring down the equal sign. And then do 16 times sine 42. Make sure the 16 comes first and not the sine 42. Always put the number first. So we have X sine 110 is equal to 16 sine 42. We want to solve for X, get the X on its own, so we're going to divide both sides by sine 110. We always divide by whatever is stuck onto the X. And what we do to the left, we do to the right. These will cancel. Technically, we'll get one X on the left, which is just X. And you can stick this into your calculator then, 16 sine 42 over sine 110. Make sure you're in degree mode. We get X equal to 11.3931 and correct to 2 decimal places. The 9 is the rounding digit because that's the second decimal place. The 3 is the telling digit. The 3 tells the 9 to rest. So 5 or more, let it soar. 4 or less, let it rest. So we get X is approximately equal to 11.39 meters. Don't forget your M for meters. That's for 10 marks. Part 2, find the area of the triangle BCD, correct to 2 decimal places. So BCD, it's the same triangle that we were looking at in part 1. So the angle DCB is 180 degrees minus 42 degrees minus 110 degrees, which is 28 degrees. We worked that out in the last slide, but I'm just putting the rough work here again. So we can fill in 28 degrees here. Don't just write down 28, show your workings, show where you're getting it from. We're subtracting from 180 because the angles in a triangle always add up to 180 degrees. So we're going to use this formula, half AB sine C, which is the area formula from page 16. So area is equal to a half AB sine C. The side BC is equal to 11.39 meters. We worked that out in part 1. So I'm going to draw that in, 11.39 meters. I'm going to relabel capital B as capital C because I need the 16 and the 11.39 to be the A and the B. We don't know this length here, DC. And if we have a look at our formula, the two lowercase letters are A and B. So the lowercase letters stand for the sides. So the sides that we have to be A and B. Therefore, the angle in between them has to be capital C. So it doesn't matter if you call the 16 meters A and the 11.39 meters B, or vice versa, so long as one of them is labelled as A and one of them is labelled as B, because they're the two lowercase letters in the formula. So if that's lowercase a, then this must be capital A. And if this is lowercase b, then that must be capital B. So your other angle here must be capital C. So we replace the capital B with capital C. So the 28 degrees is going to be subbed into our formula in place of that capital C. So subbing into the formula, the lowercase a is 16. The lowercase b is 11.39. And the capital C is angle C, which is 28 degrees. And then you can just stick it into the calculator, making sure you're in degree mode. And we want to round to 2 decimal places. So the second decimal place is our rounding digit. So the 8 tells the 7 what to do, and it tells it to round up. So we get approximately equal to 42.78 meters squared because we're dealing with area for 10 marks. Part B. Find AB correct to 2 decimal places. So I'm going to label the side AB as X. So we are looking at a different triangle now in part B. So we know 28 degrees, so I'm going to fill that into my picture. And we know 11.39 meters, I'm filling that in as well. So the angle BDA, so BDA, so this angle here, is going to be 180 degrees minus 63 degrees minus 42 degrees, which is 75 degrees. Because these angles here are on a straight line, and the angles in a straight line add up to 180 degrees. So that's 75 degrees. So 63, 75 and 42 together add up to 180 degrees because the angles on a straight line add up to 180 degrees. So we're going to go with the cosine rule here, which is on page 16 of our formula book. But really you should always try the sine rule first, and if that doesn't work, then try the cosine rule. But as it turns out, the cosine rule is what will work here. So here's our cosine rule. A squared equals b squared plus c squared minus 2bc cos a. So I'm going to replace the angle D with the 75 degrees. I'm going to replace that with capital A. And the side that we're looking for is lowercase a. Then I'm going to call one of the sides of the triangle, one of the other sides, as B. So since this is already angle B, we may as well let this be lowercase b so that we don't have to relabel too much. And we're going to have to relabel this capital A as capital C. And then the 16 meters will be lowercase c because we can't have two capital A's. So it's best to let the lowercase a be the side that you're looking for, because when you sub into your formula, then you can just put everything straight into the calculator. So it's a lot easier. So we were looking for the side AB. So I'm calling that X. And then I'm labeling it as lowercase a, because in our formula, the A is on its own. Also, this is the angle that we know, and we don't know these two angles here. So if we have a look in our formula, we have a capital A in our formula. So the only capital letter in our formula is A. So therefore the angle that we're using must also be called capital A. So there's a few reasons why we should label our triangle in this way. So then we can start subbing into our formula. So A squared is just going to be x squared. We don't know what that is yet. B squared is going to be 10 squared. Plus C squared is going to be plus 16 squared. Minus 2 multiplied by B. So in place of B, we're going to put 10. And then we're going to have C. So we have a set of brackets. And in place of C, we'll have 16. And then cos A will be cos 75 degrees. So you can just stick that into the calculator. And you get 273.178. So we weren't looking for x squared, we're looking for x. So we get the square root of 273.178. And that gives us 16.528. And we want to round to 2 decimal places. So the 2 is the rounding digit, the 8 is the telling digit, the 8 tells the 2 to round up. So we get approximately equal to 16.53 meters, and that's for 5 marks.